Hi, and welcome to another video on object-oriented programming in C#, with me, Marinas Toman. Okay, so just a quick revision over an introduction to classes and objects and everything that we've kind of covered this week. So, object-oriented programming, what's the point of using object-oriented programming? And it's really about creating objects that contain both data and methods. We have a lot of advantages over just procedural programming. It's faster and easier to execute, provides a clear structure for programs, helps to keep the C# code dry, so don't repeat yourself, makes code easier to maintain, modify and debug, and it makes it possible to create full reusable applications with less code and shorter development time. So hopefully we've shown that, from some of the different ways that we can use getters and setters and constructors and different access specifiers and even the static keyword. So really with object-oriented programming, what we can do is we can start now to program things about the real world. We can give our objects not just that we're storing data, but we can give them methods as well. Our objects can now do things, and they represent real life objects. So in this example, a class would be a fruit, and then the object would be the instance of that class, the specific instance. So it would be apple or banana, or a car would be Volvo or Toyota. So the class is really a blueprint or a template for an object, and the object is a specific instance of that class. When individual objects are created, they inherit all the variables and methods from the class, so they basically get their own copy. Okay, they get a copy of everything. So classes, we looked at how we declare a class. So we have the class keyword. Classes have members, so members are fields, properties, or methods. We can create objects, so you can see here the default constructors being called, and then we can access fields with the dot notation as well. And then we can create multiple objects, so this is where it starts to become more powerful. So we can have one class that's the object or the template or the blueprint for an object, and then we can have multiple instances of that class. And it's better then if we start to break up, so if our classes just go in their own programs, okay, this is better practice for us, and also good practice. You'll see in the Ulster coding guide that this is the name of the program in this instance here, but you'll normally name your program the same as your class. Okay, that's good practice to do that. So whatever your class name is, that's what your program name is going to be. So what we can do is we can encapsulate the class in its own file, and this is the way that we want to do it. This is a better way to do it, and use some access modifiers then to get access to our classes or our fields, the objects fields. So the different types of members that can be in a class are fields, methods, constructors. So as you can see in this example, we have 2 fields, 1 method, so there's 3 members altogether. You can, if we talk about the access modifiers as well. So if you don't have any keyword here, this is going to be private by default, so it can only be used inside the class. But in this example, because inside the class, we can access it with the dot notation, and we could leave our variables or fields blank and then set them at runtime whenever we're creating a new method or a new instance of our class. So we're creating a new object. the access modifiers that we looked at are really public and private. Private keeps access just within the class, and then public gives us access to members from outside of the class. So this member here will be able to be accessed outside the class like this, but this is invalid because this member is private. Okay, so this you can't you can't access like this a private field. So public and private modifiers, we really need these to achieve encapsulation. Okay, it controls the visibility of our class members, and this helps us make data sensitive, and it's really done by declaring fields private, and also by the use of properties as well. So whenever we to achieve encapsulation, we have to declare fields private and then provide public getters and setter methods through properties which access and update the value private, or the value of the private field. So we see here that this is the better, our better preferred option to way to do it, because this achieves encapsulation. So what we can do is provide a getter method that just returns the private field, and then a setter method that sets the private field, and we can encapsulate that inside a public property. And normally good convention is to have the property with a capital and the field with a lowercase. Yeah, so in this example you can see we're setting through the property the value, and then we're retrieving it again through the property. We looked at the shorthand, so properties can just, you don't have to put the body of the getter and setter in, you can just use the keyword get and set followed by semicolons, and this will do the exact same thing as this here. So it's just, once you're comfortable setting and understanding how the getters and setters work, then you can just use the shorthand, because it's a lot easier. And then we looked at constructors. So this is really a special type of method inside the class that is really just used to initialize values to the fields within the class whenever an object is being created. So the advantage of constructors, when it's called, an object of class is created and it can be used to set initial values for fields. Okay, and we talked about this, the default constructor. A constructor has to match the name of the class, and it cannot have a return type. And if you don't, it has to have an accessor type as well, or an accessor keyword. It has to be called. So to create an object, you're basically calling a constructor. So you're saying construct an object of this type. Give me a new piece of memory, and now let me reference that, this new piece of memory, I can just call it forward. So anytime I need to access that memory, I have a reference to it here. So constructors are very important. All classes have them by default, but if you do not create your own class constructor, C# basically creates one for you that just allocates some memory to the fields. But it's always good practice, to implement your own if you can, which just sets some initial values. So let's say, for example, if this was a bank account and you had a double for your account balance, and when you're creating a new bank account you might want to set the balance to 0. So you would do that in your constructor, because you want to set that as soon as it's created, or as soon as it's the object is constructed. So they really do save time. We can pass in our own variables as well, so we can define our own constructors that basically initialize our fields with some parameter or some argument that's passed in at runtime. We can overload the constructor as well, so we can have multiple constructors. because of the same name, because they all have to be named after the class, but the difference is to overload them we can have different types of variables or different number of variables. And remember, the order and the type and the number of variables is important. It must be followed. So that's the custom constructor, and then you can see, the constructors save time, because this is how we would have had to create, if we didn't have a constructor and we just created our header fields, with no, we let C# create just a piece of memory for our fields, then we would have to, give them the initial value. So, this kind of 4 lines could be done now in just this one line, because the initial values can be passed into the constructor that we have created that sets our fields up with these initial values. And then finally we looked at the static keyword, which really just is the class keyword. So it keeps things when static keywords used, a field, whenever an object is created of a class, that object doesn't get a copy of that member. If there's a member that's static, then let's say in this example, you've got a static method and a static integer, then whenever this, whenever an object of this class is created, they don't get their own copy of these. You get a copy of everything else that isn't static, but static stays with the class. The objects don't get their own copy of that, and it can be accessed in a different way as well. So that's pretty much everything for classes and constructors and objects in C#. Okay, so that's everything for the video. Thanks for watching.